Hi viewers, this is Sri Ramulu. So before watching this video, please subscribe it. Today's topic is active element, passive element, and a power source. First, what is the active element? What are the active elements? The elements which are capable of supplying, amplifying, or rectifying electrical energy are called active elements. Active elements means which are supplying, amplifying, or rectifying the electrical energy. Those are called simply active elements. Next, examples of active elements and their actions are listed below. See their action. Suppose these are the active elements: battery, generator, transistor, diode, junction diode, and Zener diode. So what are the uses? What are the actions of these active elements? First one, battery. Battery, main use of battery is to supply the energy. And a generator is also, it is used to supply the energy. Transistor is used to amplify the signal or energies. Junction diode can act as a rectifier, or it is act as a rectifier. Okay, next, fifth one, Zener diode can act as a voltage reference diode or voltage regulators. Voltage regulators or voltage reference diode, or another name is voltage stabilizer. Voltage stabilizer. Stabilizer means which makes constant. These are called active elements. Next, passive elements. What are the passive elements? The elements which receive electrical energy from, not it is a form, it is a from a source like battery, and converts into heat or light and stores in the form of electrical or magnetic field are called a passive source, right? So what are the passive source or passive elements? Passive source or passive elements same. Active source or active elements are same. Okay, so are called passive elements only, not source here. Here elements which receives electrical energy, so it is from where? From sources like battery, okay, and has to convert into either light, either heat or light, and store in the form of electrical or magnetic field are called passive sources. So like this, passive sources has to convert either into light or heat, or they have to store the energy in the form of electrical or magnetic field. Those are called. These elements can control flow of electrical energy but cannot amplify the energy. If they amplify, then what we call them as active. So they cannot amplify. So that is why they are called passive elements. So here list is given for passive elements and their actions also. Passive elements and actions. Resistor, how does it act? It acts to convert electrical energy into heat. It converts energy into heat. Bulb converts energy into not only light and also heat. Switch, it acts as a open or closed path for electricity. Capacitor stores energy in the form of electric field. Inductor, it stores energy in the form of magnetic field. Okay, if it's formed in electric field, stores electric field, that is capacitor. Capacitor can store energy in the form of electric field, and inductor can stores the energy in the form of magnetic field. So these are the active and passive sources. Now power sources. What are the power sources? Batteries and generators are general sources of electricity. Okay, so we know the battery and a generator can generate the electricity. Power source drives electrical current into an circuit at some potential. When we have the potential, then only power source can make them to transit or travel or transfer in circuit. Okay, so without potential they cannot transfer, electricity cannot flow. Now, in the working of electric or electronic instruments or circuits, voltages and currents plays a major role. Okay, suppose electronic circuits or instruments has to work, then voltage and current are plays major roles. That is why here see, power sources are broadly classified into two categories, namely voltage source and current source. That is the reason if any circuit want to run, which are important, voltage and current are very important. So that is why power is broadly divided by their working as voltage sources and current sources. And these sources are independent sources, they cannot depend on one another, that is independent, they are independent source. So that is sometimes we call them as independent voltage source, independent current source also. Now let me enter. Independent voltage source. A voltage source whose terminal voltage is constant. Terminal means output voltage, right? The voltage source whose terminal voltage is constant, or we can define like this also, or a predefined value. Predefined value means before give circuiting or before connecting the circuit. Suppose if you keep the voltage something, let like this 2 volts or 20 volts like this, it is a predefined, before predefined. That is also called as independent voltage source. And see, it's a mathematical expression. So mathematically how we express voltage source, V is equals to V of t, means voltage depends on time. As the time changes, voltage also changes. So that is why it is called voltage is a function of time, right? Is an independent voltage source, it is expression. Its terminal voltage is well defined and do not change in circuit elements. So here terminal voltage means output voltage, it is well defined, it cannot change. Okay, cannot change in circuit elements, current and physical conditions like temperatures of the network also. Okay, temperature of the network, current and circuit elements cannot change the terminal voltage, means output voltage, it is independent on elements, current and physical conditions like temperature. So that is why independent source it is. Symbolically, independent voltage source can be represented as shown in figure. So like this, see what are the figure in the figure. So it is a output, it is also output terminal voltage, output terminal source. So like we can denote like this also, or we can denote like this also. Okay, so different forms are there. Sometimes we denote like this and sometimes we denote like this, voltage sources. Next, an independent voltage source is an ideal source. Yes, independent source is an ideal source. Practically, absolute independent voltage source do not exist. Yes, it really cannot exist. Why? Because here see what is the terminal voltage is well defined, do not change is given. Okay, but terminal voltage changes practically. With what? With circuit elements, currents and physical conditions like temperature. If the temperature changes, output voltage also changes. current changes, output voltage also changes. Elements like resistor, capacitor changes, then also changes. But practically it cannot happen. Practically it is not independent. Practically it is dependent, but it is ideal condition. Ideally it is independent, but practically not independent. Practically it is dependent. Why? Because practically their value changes with what? These conditions. Okay. Next this one. Because no source can supply power infinitely at constant voltage. Suppose I kept voltage as 2 volts constant, okay, and let it is supplying the current continuously, but then ideal condition, what this voltage cannot change, then it is called independent. But practically what happens, when current is flowing slowly, then after certain time this voltage changes. It is practically, but ideally it cannot change at constant, because no source can supply power infinitely at constant voltage. Yes, it cannot supply infinitely. It is practically within a specified limit of maximum current for a limited time. Up to certain limit only it supply the current continuously, power supplies the power continuously, but beyond the time, then what happens, that it cannot supply the power continuously. A voltage source can maintain terminal voltage independent on load condition. So whatever load you use, it cannot depends on the load. In this network, sources are independent of circuit parameters and physical condition. Okay, at ideal condition, what? At ideal condition, it is independent on circuit parameters and circuit physical conditions. Independent current source. Okay, so by that independent voltage source is over. Now independent current source. A current source whose output current is constant. What I explained in the independent voltage source, same thing present here, but in the place of voltage, current will come. Okay, suppose if you learn the voltage independent voltage source completely, then independent current source no need to work hard, it easily comes. Okay, a current source whose output current is a constant or predefined value. Okay, so here also output current is constant for independent current source, or a predefined value is also, if you have the predefined value, it cannot change. Okay, so that is a current independent current source, and it is mathematically how we express it is I is equals to I of t, means current is a function of time, right? Current depends on the time, that is the meaning. Is an independent current source. Its output current is well defined and do not change with the changes in the circuit elements or physical conditions like a temperature of network. And a independent current source is what? Independent current source, its current value cannot change with what? Cannot change with circuit elements or physical conditions like temperature. Okay, but for what? It is independent source only. Symbolically it is expressed like this. Symbolically, see, it is current. For current, arrow mark we have to show. For voltage, no need to show arrow mark, just to place it is like plus minus, or you can draw this diagram also, already shown above. Okay, it is shown. An independent current source is also an ideal consideration. Yes, above one is ideal consideration. Practically no source can supply current independent of circuit parameters and physical condition. Yes, so generally we know that as the temperature changes, current also changes, right? So it is for practically, but ideally it is independent, but practically it is dependent. Okay, next, because a practical source can have limited charge and delivery capability. Yes, For example, there is a circuit which is producing the current 2 amperes. After certain time it cannot produce 2 ampere practically, right? Practically it cannot produce. If you say it is ideally it produce a current 2 ampere forever. Forever means after 20 years, after 30 years also it gives the same current. But no current, no source present ideally. All the sources present, only practical sources present on the earth. Okay, so that is why they have the limited charge and delivery capacities. Capability means capacity. Within a specific limit of circuit parameters and time, current source can supply the current to the load independently. Yes, within the certain time only it applied to the current supplied to the load independently, but after certain time it depends on the load. Okay, next, last point. The reason for choosing an independent current source in the network analysis. Okay, this is the reason for choosing this things as independent in network analysis. Okay, in network analysis mostly we want voltage source and current source. So that is why here certain explanation and certain things about them. So okay friends, thank you for watching this video. Thank you.